So this one, 20 small cubes with side lengths 1 centimeter are combined. According to the pattern shown below, find the surface area of this irregular shape in square centimeters. Okay, so for this question, with the acceleration class, I've taught you before the way to think about this question. And for my mastery lessons, my mastery students, let's see if you agree with me with this statement. Okay, so think about the 4 views, actually the 3 views of this irregular shape: the front view, the side view, and the top view. Okay, so that we actually have 3 pairs of views. If we have the front view, we will definitely have the back view marked in red, the back view. If we have the right view, we will definitely have the left view. And if we have the top view, we will also have the bottom view. Okay, I'll mark them: back, left, and bottom. So, see if you agree with me with this statement here. I say that the surface area of any shape, whether it's regular, irregular, or not, the surface area of any shape is the sum of all these views. Yeah, do you agree with me? So the front view plus the back view plus the left view plus the right view plus the top view plus the bottom view will give me the surface area of any shape. Yeah. Okay, so with that being said, let's have a look. Let's start with the front view of this shape. Okay, so the front view, let's count together. Because we know that the small cubes, they all have side length 1 centimeter. So this is 1 cm. That means one face. One face is 1 by 1. So the area of one face will be 1 times 1, which is 1 square centimeters. So we just need to count how many faces we have, and that will be the area. Okay, so let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 for the front view, when we're looking right at this shape. And here comes the second key point. See if you agree with me. The front view and the back view of any shape will be the same, will be identical. It will be of equal values. So if we have 9 square centimeters for front view, and this will also be the value for the back view, the area for the back view. Okay. And then let's count for the left. So sorry, for the right view, because we can see the right view. I'll mark it again in red pen. Actually, I'll change the color. I'll change it to blue. So we have, let's start from top to bottom. 1, and then 2. Sorry, that's not the 2. The 2 is over here. And then 3, 4, 5, 6, 7. So the right view is 7 square centimeters. The reason why we're not counting these 3 faces is because they've been covered. If you consider it, if you're looking at the shape from right to left, do you see this cube first? Do you still see this cube? No, because it's been blocked by the cube in front. And it's the same for this one in the middle. It's also blocked by this one, the third cube. And for this one, it's blocked by the 5th cube. We only see 2, 3, 5. We don't have X-ray eyes like Superman. We cannot see the blocks that are blocked behind. Even Superman cannot see them because X-ray doesn't work that way. But anyway, let me just write the right view over here. So this is the right view. The area of the right view is 7 square centimeters, and it's the same for the left view as well. Okay, and the last part is for the top view. The top view, which is the same as the bottom view. So I'll use purple for top. Okay, so let's count again. 1. Okay, again from top to bottom. So 1, 2, 3, 4, 5, 6. This is a quite common mistakes students make. They won't consider this one. 7, 8, 9. There's nothing here. 10, 11. Okay, so they don't have to be at the same height, everyone, to be at the top for the top view. Yeah, as long as there's no cubes blocking it, you will see it on top. Okay, so we're looking from top to bottom. So you see, we have 4 in the top row, and then 1, 2, 3, 4 with the second row, and 3 with the third row. So altogether, 4 plus 4 plus 3 gives us 11. 11 square centimeters, and it's the same as the bottom. Sorry, poor handwriting. Apologize. Okay, so we know the front equals to back, the right equals to left, the top equals to bottom. So we can find the surface area pretty easily just by having these 3 numbers added up and then multiply by 2, or you can also do it the other way around. 9 times 2 plus 7 times 2 plus 11 times 2, which is the same thing as 9. So if you take out the common factor 2, that would be 9 plus 7 plus 11. Altogether multiplies 2, and that will be 9 plus 11 is 20, number pair. 20 plus 7 is 27. 27 times 2 is 54. And 54 square centimeters is the answer. Okay, and let's move on to the third bonus question. This is the last one for 3D shapes. Actually, the rest, I think we have 7 or 8 bonus questions, all for arithmetic progression, because it's indeed a bit abstract, needs more practice with that. So there's a cube with an edge length of 2 centimeters, which is the large one on the right, on the outside. And this is 2 cm. And Jim digs a small cubic hole with an edge length of 1 centimeter from the top face of the cube. What it means is basically so from the top of the 2 centimeter cube, we dig a new 1, 1, 1. So the dimension is 1 times 1 times 1. New cube. So this is, let me change the color. This is 1 cm. Okay. And on that basis, we dig another 0.5 times 0.5 times 0.5 cube from over here, as you can see. I'll mark this length over here as 0.5 cm. Now, I've marked all the information we get from the question. And the question is asking for what is the surface area of the final figure. Okay. Right. I'll give you 10 seconds or 20 seconds to have a look at this question. Have a think, and then I'll go through it. If you have done tons of geometry problems, tons of questions asking you to find the surface area, then you should be able to develop an instinct, a geometrical instinct. What you should do with this shape so that it will make your life easier when finding the surface area. Okay. All right, time's up. Let's have a look. So this might require you have some spatial imagination, but let's see if I can draw it clearly. I am confident with my drawing. I'm an artist after all. So with this, let's look at the smallest cube right here. It's been digged, so it's not there. Okay, so it's hollow, right? That's the word. So if you look at the bottom face over here, the face I've marked red. Yeah, the bottom face of the 0.5 times 0.5 times 0.5 cube, and we can translate it up. Yeah. Over here. We're not changing its area. The area is the same, the value is the same. We're just translating it one level up, yeah, to the 1 times 1 times 1's cube. And then if we include the outskirts of the bottom face of the 1 centimeter cube, which is, let me change the color, purple perhaps. Well, actually, I should have used purple for the bottom face, but whatever. Maybe green, okay. The outskirts are like this. Right. So I have marked the bottom face of the 1 cm edge length cube. Right. So we have a square, a 1 times 1 square right now for the green face. Yeah. The green face is only made whole when we move the red face up. Yeah. And now we're in the middle. Yeah. The green face is in the middle. And if we move the green face vertically upwards, if we translate it vertically upwards over here. Again, we're not changing its surface. Again, we're not changing its area. We're just moving it. And we're just changing its position. The area is 100% identical. And now you see, if we include the yellow, sorry, not yellow, the violet outskirts on top of the 2 centimeter square, the 2 centimeter cube. So the violet face is actually the top face of the large cube on the outside. Yeah. So moving the red face up and moving the green face up, we have made this whole face whole. Okay, we have made it whole. So we don't need to consider we don't need to consider the top face or the bottom face for the small cube, the top face and the bottom face for the middle cube. Yeah, we just need to consider the surface area of the largest cube, and then 4 new faces, the front, the back, the left, and the right. Yeah, 4 identical faces for the middle cube and the small cube. Okay, I hope that's clear for you. And let me see if I can make it illustrated a bit more clearly. I think it will be clear. I mark the outline of this cube red, this cube red as well. And I'll mark this cube, right? So this square in the middle, red, so you can see what we've been doing. Yeah, that's pretty much it. Okay, it's just like an elevator. Okay, now let's do the calculation. So the surface area, hope you're all happy with how we find surface area for cubes. The surface area for the largest 2 centimeter cube is, we find the area of one face, which is 2 times 2. Yeah. And how many faces are there for a cube? 1, 2, front, back, 1, 2, left, right, and then 1, 2, top, bottom. So altogether, there are 6 faces times 6, and that will be 24 square centimeters. Okay. And then on that basis, since we've been digging the 1 centimeter cube and the 0.5 centimeter cube, so we've been generating each time 4 new faces. We just do plus 1 times 1, which is 1 face for the 1 times 1 cube, times 4. Since we've been generating, we only need to consider the four faces that are standing. And then plus, and this is 4, then plus 0.5 times 0.5 times 4, which is this 0.5 times 0.5 is 0.25, and 0.25 times 4, this is also a number pair. Be familiar with it. 4 times 25 is 100, and 0.25, we just divide 100 by 100, which gives us 1. So 24 plus 4 plus 1 will be 29. So the answer is 29 square centimeters. Okay, that is the last question for lesson 5, last bonus question. Okay, and don't worry, I will send all these pictures, these notes to you, either PDF or JPG. Okay, so don't need that much time to do them now. Okay, let's move on to bonus questions from lesson 4, arithmetic progression. So the first one, if you continue the sequence 1, 2, 4, 7, 11, 16, write down the smallest number, which is greater than 50. So let me write the sequence over here. We have 1, 2, 4, 7, 11, 16, ... So let's look at the difference first. Obviously, there is no common difference over here. So there's just difference between 1 and 2. The difference is 1. Should probably change the color. Between 1 and 2, the difference is 1. Between 2 and 4, the difference is 2. The pattern is starting to show, right? Between 4 and 7, the difference is 3. Between 7 and 11, the difference is 4. Okay, so now we definitely have a pattern. Between 11 and 16, 5. So you see, the difference for this sequence itself is an arithmetic progression, yeah, with the common difference 1. Let me change another color. This is what we call quadratic arithmetic progression, meaning that the difference is an arithmetic progression. Okay, so to do this, a simple way is you consider this sequence, yeah, the one that is actually an arithmetic progression. So we want, and also remember to include the first term, yeah, because all the terms in the actual sequence, the 1, 2, 4, 7, 11, can be obtained or acquired by using the sum of the arithmetic progression, the red one over here, plus 1. Yeah, the 2 is 1 plus 1. The 4 is 1 plus 1 plus 2. The 7 is 1 plus 1 plus 2 plus 3. So you see, 1 plus 2, 1 plus 3. We're always adding the 1 at the beginning, yeah, the first term. So the question is asking for the smallest number, which is greater than 50. So it's basically just the first number that exceeds 50. That's what the question is looking for. So 1 plus, let's say, I don't know what number we're looking for. What is the last term in this arithmetic progression we're looking for? So let's just say it's n or x. Personally, I prefer n. So 1 plus n. And if you remember, the formula for us to find the sum of an arithmetic progression is 1 plus n, first term plus last term, times number of terms, which is n, just itself. Now, for example, if the last term is 5, because the common difference is 1, they're consecutive numbers, and there are a total of 1, 2, 3, 4, 5 terms. So if the last term is n, then there will be n terms, yeah, and then divided by 2. Okay, so this actually is a bit hard for us to solve. That we want it to be greater than 50, and plus 1 should be greater than, let's just say, let it equal to 50. All right, and right now, because this requires us to solve the n plus n squared, we don't know how to solve n plus n squared. So let's just try some numbers, shall we? So we know that 1 plus 2 plus 3 plus 4 plus ... plus all the way to 10. This we know. This is 55. Okay. And yeah, that actually gives us the answer. Yeah. So just use some featured sums. So 1 plus to 100, 1 plus 2 plus 3 plus 4, all the way to 100 is 5050. These are some characteristic sums that I recommend you can keep this in your heart, keep this in your mind. Yeah. And then 1 plus all the way to 100 is 55. 1 plus all the way to 99. 1 plus all the way to 9 gives us 45. Yeah. These are just some characteristic sums. And because we're looking for greater than 50, so the last term should be 10. Because if we have 1 plus 2 plus 3 plus ... plus all the way to 9, we will have 45. And 45 plus the first term gives us the term, I think the 9th term or the 8th term, that is 46. Yeah? 46 is less than 50. And for it to be greater than 50, we'll need to add the 10. Yeah, so 1 plus all the way to 10 gives us 55. And 55 plus the first term, the 1 over here, is our target number, 56. So the answer is 56. Okay. Right. I hope this is clear. If it is not clear, you can ask me your question at the end of the office hour. For now, let's move on to number tables. So here's a number pattern. We have a number table with A, B, C, D, E, 5 columns, and with infinite number of rows. So the first question is asking us to complete the next 2 rows of the table. It is easy. We're just writing consecutive numbers. Just be careful with the order. Be careful with the direction. For the first row, we are moving from left to right. For the second row, we are moving from right to left. For the third row, we're moving again from left to right. And then for the fourth row, we are moving from left to right. Sorry, from right to left. So you see, for odd rows, we are moving in the direction, in the positive direction, I'd like to say, or from left to right. While for even rows, we are moving in the opposite direction, in the reverse direction from right to left. Just keep this in mind. It will help us later on. So let's keep writing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 17. Oh, sorry. For odd number rows, we start with column B. So 17, 18, 19, 20. And then for even number rows, we start with column D. So 21, 22, 23, 24. Right, that's question 1. And then question 2, what number is in the 1001st row of the C column? So it's asking us for the C column. So let's look at the C column, shall we? The C column is 2, 6, 10, 14, 18, 20, 22. So there is obviously a pattern. There's a common difference between each term, and we find that it's 4. Yeah, 2 plus 4 is 6, 6 plus 4 is 10, and then 4, 4, 4. Remember, we've gone through the general term method, and this is where we want to use that general term. It speeds up our calculation, makes life super easy. So because remember the 3 steps, everyone, let's go through the 3 steps again. The first step is find the common difference, 4. Write it down. The second step is write an n after the common difference, the 4, so 4n. And that gives us a sequence, 4, 8, 12, 16. We got the sequence because n is always the same sequence. N is always 1, 2, 3, 4, 5, all the way to infinity. And 4n is 4 times 1. Yeah, gives us the first term when n equals to 1. The second term is when n equals to 2. That is 4 times 2. And the third term is 4 times 3, which is when n equals to 3, the third term. Right, so that's how we got the 4, 8, 12, 16, sorry. Sequence. And then we compare this sequence, we compare the first term actually with the first term we actually have. So we want to start with 4, but instead we are starting with 2. So how do we get from 4 to 2? We simply take away 2. So subtract 2 is how we got the general term. So 4n minus 2. Yeah. So you see 4 minus 2 is 2, 8 minus 2 is 6, 12 minus 2 is 10, 16 minus 2 is 14. So we can use the 4n minus 2. We can use this expression to express any term in this arithmetic progression. Any term in the C column. Okay. So we got the general term. And the question 2 is asking for what number is in the 1001st row. So in other words, we're actually looking for the 1001st term in this arithmetic sequence, meaning that we simply need to equate n with 1001, and that will give us the sum. So 4 times n minus 2 is not the sum, but the target term. So 4 times 1001 minus 2, and that will be 4004 minus 2. So the answer is 4002. Easy peasy. And then the last question, where will 2022 appear? Okay, so here we will need to find cycles in the number table. Let's try to find a cycle. Actually, for those of you who are observative, you might have already noticed that we have 2 rows as a cycle. Yeah, an odd number row and an even number row. Odd number row, even number row. Odd number row, even number row. So we have 2 rows in a cycle, yeah, which means we have 8 numbers in a cycle. You see, in each cycle we have from 1 to 8, and then from 9 to 16, so 8, 16, 24, and so on. And so we're adding 8 at a time. So one cycle contains 2 rows and 8 numbers. Okay, remember this. And so for 2022, we actually have 2022 numbers. So we simply need to take 2022 divided by 8, which is 2. So let's do a division over here. 2022 divided by 8. This is 2. 2 times 8 is 16. 42. And then 5, 40, 22. Then 3. No, 2. So this is 16 with a remainder of 6. So the answer is 252 with a remainder of 6. All right. So this means the quotient and the remainder tells us that we have completed 252 complete cycles. Yeah. And in each cycle, remember, we have 2 rows. Yeah. Don't just write 252 at the row number over here. That's a typical wrong answer. First of all, we need to start a new cycle. Yeah. And so to start a new cycle, we first look how many rows have we completed. So it's 252 multiplied 2, because there's 2 rows in a cycle. So we have finished 504 rows. Okay. And then to start a new cycle, we move on to the next row, the 505, row number 505. Okay. Pardon me. And then we look at the remainder 6, meaning we have 6 numbers remaining. And actually, you can just have a look at the first cycle, the 1, 2, 3, 4, 5, 6, 7, 8, to help you. We have 6 numbers. Let's put them in, starting with odd number row always. So we have 1, 2, 3, 4, 5, 6. Yeah, 6 numbers. Putting them in, and the sixth number will be at column C. And then row number, because this, okay, we're starting with row number 505, but we can only put 4 numbers in row number 505. That means we'll have to move on to the next row, row number 506. So row number 506, column C is our answer. Okay, that is this question. Let's move on to the next one. So a sequence of numbers, yes. Okay, Olivia, you have a question?
I didn't understand the first part. The first one was the last question.
Yeah.
The first question, I didn't quite understand.
You mean this one?
No, like, I mean.
Oh, this one, right? This one.
Yeah, that one. Yeah.
The first question.
I meant 2. I meant number 2.
Oh, question number 2. Okay, I'll go through it at the end of the office hour. Okay.
Okay.
Yeah. Right. Moving on. So a sequence of numbers is formed by always adding the same number to get the next number in the sequence. This is useless information, won't help us. The actual question is over here, starting from the 3rd row. The 10th number in the sequence is 23, and the 15th number is 38. What is the 102nd number? This should be easy. First, we find the common difference, which is just find the sum between the actual numbers, 38 minus 23. And then, sorry, not the sum, the difference. And then find the difference between the term number, 10 and 15. So 15 minus 10. This will give us 15 on top and 5 at the bottom. So divide them. 15 divided by 5 gives us the common difference, 3. And let's go through the steps again. But this time, the order will be a bit different. So first of all, the first step, we have the common difference, 3. And then we will have 3n. But this time, we won't generate the 3n sequence, not anymore, because we are given that the 10th number is 23. So the 10th number for the 3n sequence, the 10th term should be when n equals to 10. So that will be 3 times 10, 30. And then we see to get from 30 to 23, what should we do? Yeah, we minus 7. That is pretty obvious. So that means to get the actual all the terms in the actual sequence in this arithmetic progression, we will need to take away 7 for all of the terms in the 3n sequence. So it's 3n minus 7. This is the general term. This is how we got the general term. You can also use 15. That's no problem at all. So 3 times 15, because that's 3n. 15th number means n equals to 15. And 3 times 15, compare it with 38. This is 45, this is 38. How do we get from 45 to 38? We take away 7. So you see, all of the terms in the 3n sequence will need to take away 7 to get our actual term right here. So good, we got the general term. Let's find the 102nd number. Could be easy. 3 times 102, because the 102nd number means n equals to 102. And then remember to take away the 7. So this will be 306 minus 7, and the answer will be 299. Okay. Right, this one is easy. And let's move on to the next one. Okay, this one, on first look, it will seem like a simple find the sum of an arithmetic progression to you. But if you have another look, if you look at it a bit more carefully, you will see that we have 1 plus 2, but not adding 3. We're omitting the 3. So skip 3, plus 4, plus 5, skip 6, plus 7, plus 8, skip 9, plus 10, plus ... And we can say confidently that we're skipping 1998. Yeah, because it is a multiple of 3. It is divisible by 3. And plus 1999 plus 2000. Yeah. Right. So we're skipping 3, 6, 9, ... all the way to 1998. Right. So that actually tells you how we can solve this question quickly. So we can first look for, we can put the 3, the 6, the 9 back. Yeah, we can consider just a regular arithmetic progression that starts with 1 and ends with 2000 with no numbers omitted. Yeah? 1, 2, 3, 4, 5, 6, 7, 8, 9, ... all the way to 2000. And we know how to find that sum. Yeah? Remember the formula, first term 1 plus last term 2000 times number of terms 2000 divided by 2. Yes, Jaden. You have a question, Jaden?
Yeah, did we skip the last 2 questions?
No, because I don't have enough time to order the questions when I put them into the courseware. Remember, I went black during that 5 minutes. I was trying to fix the courseware, and when I was fixing it, I mixed up the order. So don't worry, we'll go through all the questions.
Okay, thank you.
Yeah, and coming back, let's find the sum for this one. So it's 2001 times 2000 divided by 2, which is, we can do the 2000 divided by 2 first, which is 2001 times 1000. And that will be 2001000. Okay, interesting number. And then let's look at what we should take away, because 3, 6, 9, this sequence is not there. Yeah, we let them be here, but they're actually not here. We need to subtract them. So we have 3. Let me change the color. We have 3, 6, 9, 12, 15, ... 1998. Okay, and let's find the general term. Let's find how many terms are there in total. Okay, because remember, to find the sum of an arithmetic sequence, we only need 3 things. The first term, the last term, and the number of terms. Yeah, we already know the first term, we already know the last term. We just need to know how many terms there are. You can either use the basic method, the traditional one. So last term, 1998, minus the first term, the 3, divided by the common difference, which is 3, plus 1. Yeah, this is the old-fashioned way. Or you can use the general term method. So for this one, for this question, the general term is pretty easy to find. Yeah, you see the common difference is 3. So we have 3n. And you find that the general term is exactly 3n. We don't need to do anything to the 3n sequence. It's exactly 3, 6, 9, 12, 15. Don't need to do anything. So we let 3n, we equate it with the last term, 1998. Yeah. And whatever n is, that will be the number of terms. Because for a sequence, for example, a sequence made totally with letters A, B, C, D, e dot 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 dot. The last one, and say the last term is n, and I know that it is the 50th term. Yeah, then for sure that there are, because this is the last term and it's the 50th, so there will definitely be 50 terms altogether. Okay, that's the logic behind. Right, so 1998 divided by 3, that will give us 6. 3 times 6 is 18, leaving 19, so 6, 6. So 666. There's a total of 666 terms in this arithmetic sequence. So let's calculate 3 plus 1998, first term plus last term, times number of terms divided by 2. And that will be 2000 and 2001. 2001 times 333. Because we can do 666 divided by 2 first. And on top, we have 2001 times 1000. And we're taking away 2001 times 333. So we can take out the common factor, 2001. 2001 times 1000 minus 333. And that will be 2001 times 667. I'm sure you can all do this multiplication on your own. Sec. Yes, Mina?
You missed a 0 in 1000.
Oh, yes. Thank you. So a 0 right over here. Thank you very much, Mina. I would give you coins if we were using the Think Academy classroom, but unfortunately we're not. So let me do this for you. Times 667. So this is 07, 014, then 12006, and then 12006. Be careful to align all the digits. We have 7, 6, 6, 4, 3, 3, 1. So 1334, 667. That's the answer. Not a nice number, I know. Right, moving on to the next one. In an arithmetic progression, the sum of the first 10 terms is 20, and the sum of the first 30 terms is 90. What is the common difference of this arithmetic progression? So let's say the sum of the first 10 terms. If let me write the formula here first. That will give us a clue. The formula is the first term plus the last term times the number of terms, which is 10, divided by 2, which is 20. Okay. And what does that tell us? That tells us for the first 10 terms, this last term actually is the 10th term. So first term plus 10th term is 20 times 2 divided by 10, because we're moving these two to the other side. And we're moving it to the other side of the operation, to the other side of the equation. Remember from summer holiday term, we should be reversing or swapping the operation sign. Okay, so that means the first term plus the 10th term equals to 4. Okay, and then moving on. The second sentence tells us the sum of the first 30 terms is 90. So first term plus 30th term times 30 divided by 2 is 90. That tells us the first term plus the 30th term is 90 times 2 divided by 30. Okay. So this is 180 divided by 30, and that will be 6. So the first term plus the 30th term is 6. And then what do we do? We simply say this is the first equation, this is the second equation. We simply do second equation minus first equation. Yeah? And that will give us on the left-hand side, the first term minus first term, they canceled out. And then the 30th term minus the 10th term. Oh, sorry, they shouldn't cancel out. Let's just write it here on the left-hand side. 30th term minus 10th term. The difference between the 30th term and the 10th term is 6 minus 4. Yeah. So the difference is 2. And there are 20 common differences between the 30th term and the 10th term, 20D. Okay, and that gives us the common difference, D, equals to 2 divided by 20, which is 1 over 10, which is 0.1. So the common difference is 0.1. Then it will be an arithmetic sequence that looks something like this: 1, 1.1, 1.2, 1.3, dot, 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 dot. Something like this. Okay, hope this is clear for you. Draw a red line over here. Okay, moving on to the next one. There is an arithmetic sequence. The sum of the first 9 terms is 99. The sum of the first 27 terms is 450. And then what is the sum of the first 16 terms? All right. So again, I think this is almost identical with the previous question. The sum of the first 9 terms is the first term plus the 9th term times 9 divided by 2, which is 99. And then the first term plus the 27th term times 27 divided by 2 gives us 540. Okay, and then we can find the first term plus the 9th term by doing, again, 99 divided by 9 times 2, which is 22. And then first term plus 27th term, is 540 divided by 27, and that gives us 20. 20 times 2 is 40. Okay, I'll write both steps over here. 540 divided by 27 times 2, which is 20 times 2. So the answer is 40. Right, so that tells us that the 27th term minus the 9th term is 40 minus 22. And there will be 18 common differences between the 27th term and the 9th term. This the reason why there's 18, we don't need to add or minus 1, is knowledge from summer holiday term interval problems. Okay, if you have any questions regarding this point, why we have 18 common differences, you can move back to the summer holiday term. You still can watch the replay. You've got 2 years to watch it. So and watch it. Yeah, figure this out. So 18 common differences equals to 18. One common difference is 1. So we know that they're all consecutive numbers. Yeah. So consecutive numbers, the sum of the first 9 terms is 99. We can try to find the sum. It's the sum of the first. We can try first. We need to find the first term. Okay. So 9 terms, last term minus first term divided by 9, divided by 1 plus 1 is 9. Okay. Divided by 9 plus 1 is 9. 72. Okay. So I need a bit time to figure this out. And right, let's look at the next question. I'll move back to this question after a break. Okay. Right, let's look at this one first. Well, actually, I think we've been going through some time now. I'll give you 5 minutes break, and then when we come back, we'll continue with the previous question. All right. Yeah, go have some water, and you can go to the bathroom.
Okay. Steps. Can you unmute? Oh yeah, I can do it now.
Oh yeah, I can as well.
Hey. Bye.
I'm kind of bored.
Same. See ya.
What's up, peeps?
Hi.
What was that?
A random boy called
I'm gonna
Jay.
go ahead and cuddle my rabbit now.
What the
Show us your rabbit, Mina. Yeah.
I want to
Like,
see a
你在
rabbit.
等吃东西吃。No, what the hell?
Mina. 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 Mina.
Instant rejection by Mina.
He doesn't like you now. He's not
Are
your
you guys
friend.
like all in one class, or as in with Kevin or something? Or oh, hi, Lewis.
Bruh, Olivia chewing gum in the middle of a class asking a question be like.
Oh, bro.
It's not even chewing gum, you silly baby.
You're not even supposed to be eating in class anyways.
It's a break, bruh.
It wasn't in break.
Oh, that was me eating my sandwich.
No,
that was me
before
eating my
when she was asking a question.
That was my sandwich or me eating my lettuce. Okay, chill.
How can you
Chill.
eat lettuce? I hate lettuce.
I like that.
Same. Lettuce. I hate lettuce.
I hate like one of those like very strong flavored.
Why does everyone hate lettuce? Like, what did it do to you?
They taste horrible.
It's
What you're it's not lettuce. It's an edible leaf.
Mina, turn your camera on and
It's
show us your
lettuce.
bunny.
Yeah, I want to see
He's
your bunny.
probably gone to a different room.
Oh,
Bro.
turn
When
on
you
your
see
bunny.
Mina's camera, that's her
Turn
bunny.
on your camera to
I
show us your
know.
bunny.
No,
Turn on
Mina,
your
she probably has a toy rabbit. So yeah.
No,
A toy.
The one in
the
her
same
camera
school
is
as her,
real.
but she has a rabbit. Bunny. More like
No, it's a
Lois.
fake one. It's a fake rabbit.
Lois.
What if she just secretly have a tracking device in the rabbit, and then
Yeah,
its
come
light
on.
makes the rabbit
Yeah?
move?
I
Yeah,
like bananas.
me too.
That was just so random.
I
like
will weird like
bananas,
that.
very
It
random.
will. I'm just weird like that. Okay, chill.
I'm bored.
Want to continue the break or not? If you're bored,
Yes, I want.
I want to continue.
there are two choices, everyone. You can either continue and finish the break, and then we'll actually have one more question, and then we're finished.
Break.
Or we can do the question, and then you can leave early.
Break.
Break. Okay.
Break.
I'm gonna say break if Mina tells us where her bunny is.
I want to speed up time though. That's the thing.
Roar.
Question. Because I want to leave.
Is Mina there? Ask to
What's
Mina.
that noise?
Was Mina actually in another room?
All right, then. Well, let's quickly finish these two questions so that you can leave because it's 7 o'clock already. Some of you need to have dinner. Some of you got other things to do. Right. So this question over here, we got the common difference 1. Yeah. So for example, if we start with 1, we don't know what the first term is, but let's say we start with 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now,
Bye.
no matter. Okay, I have to. Sorry, everyone. I have to mute you all again. Right, so because the common difference is always 1, so no matter what we have, if we start with 1, don't start with 1, doesn't matter. The 9th term and the first term, the difference will always be the same. Yeah, the difference is 8, because we have 8 gaps. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 gaps, meaning 8 common differences between the 9th term and the first term. So we know that the 9th term minus the first term equals to 8. And this is summer holiday term knowledge. Yeah, sum, difference, multiple. Yeah, we know the difference between two numbers. We know the sum. So we can find the sum plus difference, 8 plus 22. Divided by 2 will give us the larger number, which is the 9th one. The 9th number, which is 30 divided by 2, so it's 15. And then 22 minus the sum minus difference, 22 minus 8, which is 14 divided by 2, gives us 7. And that is the first term. Yes, Mina?
I couldn't hear. I didn't hear what was going on before. I just heard like the first term was 7.
Right. So we're basically just doing some multiple difference over here. Okay, so we know the sum, we know the difference between two numbers. Yeah. If you're still confused, you can check out the replay after we post it in the WeChat group. So yeah, right now we know that the first term is 7. And then the 9th term is 15. Okay. And then we just need to find what is the 16th term. Yeah, the 16th term. Let me erase stuff over here. Get me some space. All right. To get to the 9th term, we add 8 common differences, namely 8. Then to get to the 16th term, we will need to add 15 common differences. So we add 15 to 7, meaning that the 16th term is 22. Right. So we can do the calculation. We can do the calculation now. Find the sum using the formula. I'll erase this part. So first term plus last term, 7 plus 22 times number of terms, 16 divided by 2. And that will be 29 times 16 divided by 2 is 8. And that will be 30 times 8 minus 8. 8 times 8 times bracket 30 minus 1 bracket. So it's 240 minus 8, which will be 232. And this is the final answer. Okay, let's move on to the last question for tonight. Pip draws an arithmetic progression with 8 terms. The sum of the first 4 terms is 32 less than the sum of the last 4 terms. What is the common difference of this arithmetic progression? Right, so I think actually there's another question. We have 2 more, but as I said, this is the last one. So for the other question, for the 10th one, I will shoot a explanation video and post it in the WeChat group as well. So don't worry. So Pip writes so we have 8 terms. The sum of the first 4 terms is 32 less than the sum of the last 4 terms. What is the common difference of this arithmetic progression? Right, so the first term will be x, let's say. Then the second term will be x plus d. The third term will be x plus 2d. The third term will be x plus 3d. Oh, sorry, the first term, second term, third term, and the fourth term. And the 5th term will be x plus 4d. And the 6th term will be x plus 5d. The 7th, x plus 6d. And then finally, the 8th term is x plus 7d. The sum of the first 4 terms is this. So 4x plus d plus 2d plus 3d, which is 4x plus 6d. And the sum of the last 4 terms is over here. So it's 4x plus 4d plus 5d plus 6d plus 7d, which is 4x plus 4 plus 5 is 9, 9 plus 6 plus 7 is 13, 13 plus 9 is 22, so it's 22d. And then we look for the difference. Yeah, so 4x, okay, let me change the color. 4x plus 22d, take away 4x plus 6d. The 4x cancels out, obviously, so what's left is just 22d minus 6d, which is 16d. It is 32 less. The actual value is 32. So 16d equals to 32. And 1d is 32 divided by 16, 2, which is exactly what the question is looking for, the common difference of this arithmetic progression. Yeah, that is everything we have for today. And if you have any questions, you can now unmute yourself and ask me. Yeah, if you have no questions, you are free to leave. See you, everyone.
Was this thingy, Bob, the one that says complete the number pattern?
Which
That
one?
The number pattern one. I don't know what question.
Okay, let me have a look. This one?
Yeah. Can you please repeat how you got the row for the number 3?
Yeah, okay, no problem. So lots of students got confused over here. We need to know two things. The first thing is the number of cycles, the cycle number. Let's first see what a cycle is. So for this one over here, for this number table, one cycle is 2 rows. 1, 2, 3, 4, 5, 6, 7, 8. This is one cycle. And then the second cycle, 9, 10, 11, 12, 13, 14, 15, 16. This is the second cycle. And how many numbers are there in one cycle? We find that there's always 8 numbers in the cycle. It's fixed. It's not changing. So what I did here is, because we're trying to fit in 2000, we want to find how many, where will 2022 appear? So we basically fill in 2022 numbers and see where will the position for the last number be. So we must be completing cycles. We must be completing cycles of 8 while we are putting in these 2022 numbers. So 2022 divided by 8 gives us 222. This is the number of complete cycles. Complete cycles we've finished, not the row number. For the row number, because we have 2 rows, odd, even, first, second, we have 2 rows in each cycle, so we multiply 2. By the time we finish 252 cycles, we will also have finished 252 times 2, which is 504 rows. Okay. So let's say this is 1998. Sorry, shouldn't be over there. Last position is over here for cycle 1998. And this is the number we are stopping with 252 cycles, which is 504, row number 504. And then we keep going. We start from here, column B, 1999, and then keep going. And by the time we start a new cycle, we will move on to the next row, which is row number 509. Okay, and then we look at the remainder. We have 6 numbers remaining. That means we just need to put 6 more numbers, and then we will get our answer. We know that for each row, we can only fit in 4 numbers. So the row number 505 is definitely not enough. 1999, let's say not 1999, maybe starting with 2014. 2014, 2015, 2016, 2017. It's not enough. So we have to keep going. Move on to row number 506. Okay, this is not a good example. So -8, 2000 and let's say, sorry, -6, 2016, 2017, 2018, 2019. This is row number 505, and then we move on because it's not enough. We move on to the next row, which is row number 506, and starting from column D, because for this is 505 is an odd number row. We start with column B, but with even number row, we start from right to left, and we start with column D. So 2020, 2020, 2021. Actually, I'm giving a bad example over here. It should be 2022, because we only need 6 more numbers. So I should start with 2017 over here. So the actual case is 2017, 2018, 19, 20, 21, and then 22, 2022. So 2022 is in column C, and then row number 506. Is it clear?
Okay, thank you.
Yeah, no worries. Does that answer your question as well, Olivia? Oh no, your question is number 2.
Yeah.
All right, so let's have a look at question number 2. What number is in the 1001st row of the C column? All right. So it's asking for the C column. So let's look at the C column. So we have here 2, 6, 10, 14, 18, 22. Okay, and obviously this is an arithmetic progression with common difference 4. Okay, and this common difference 4, this here, what I've written is the 3 steps to get the general term. I hope you're still familiar with that. The first step is we write down the common difference. The second step is we put an n after the common difference and generate a sequence when n is 1, 2, 3, 4, 5, 6, 7, 8, ... And that will be the 4n sequence will then be 4, 8, 12, 16, blah, 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 blah. And then we compare it with the C column sequence, the 2, 6, 10, 14. Yeah, and because we want to start with 4 if we have 4n sequence, but we are actually starting with 2. So we need to take away 2. Yeah, and you see that for each term in the 4n sequence, we'll need to take away 2 so that it is the actual term in our actual sequence. So 4 minus 2 is 2, 8 minus 2 is 6, 12 minus 2 is 10. So that means the general term for this, the C column sequence, is 4n minus 2. Okay. The n here is the term number. Yeah. For the first number in the sequence, it will n equals to 1. For the second number in the sequence, n equals to 2. For the 50th number in the sequence, n equals to 50. So for the 1001st number, in here, the number in the term number is the row number. Yeah. So in the 1001st row, n equals to 1001. So what we do is 4 times n minus 2. N is 1001, so it's 4 times 1001 minus 2, and that will be 4004 minus 2, so it's 4004. Is it clear, Olivia? Yeah, I see Xiaoya has raised her hand. Is there a question?
Bit confused like on the first question.
The first question, you mean for the geometry one or the arithmetic progression one?
This the cubes, that one.
The cubes one, okay. Yeah, Olivia, does that solve your question? Okay, no answer. Right, then let's have a look at the cubes one. Is this the one?
Forgot to mute
I know
myself.
the
by
one
way, it
before
does
that,
help.
I think.
Okay, you're all talking at the same time, one by one. First of all, Xiaoya, is this the one?
No, I think it's the one before it.
The one, oh, the one before it. Okay, the one before it, because when I'm fixing the courseware, it's not here. All right, let me see if I can remind me what's in the first question again.
So the sound is given 20.
Ah, that one. Okay, I got it. And Sophie, did you say something?
No.
No. Okay. Any other questions, everyone? I heard someone else said something. No. Okay, then let's have a look. Let me see if I can pull out a blank page. Actually, this one is fine. Just clear the one for this. Yeah, can I get a blank page? Yes, I can. Also, can I have some geometric shapes? Yes, I can. So here's a cube. And in the question, what's asked is, so we have a 3 by 3 cube because we have 27 cubes in total. All right, just bear with me for a sec. I need to draw the shape since it's not here. Right, this is taking too long. I'll just draw it by hand. Yeah, looks something like this, right? And then it is told that some of the cubes are being shaded gray. Yeah, it's been painted gray, but we don't know how many. And some of the faces of the cubes. Yeah. First of all, the cubes. Yeah, if one cube is painted gray, not all the faces are painted gray. I can paint just one face of this cube gray, or I can paint all 6 faces gray. Yeah, it's arbitrary. It depends. We don't know that for sure. And as for this question, the faces that are painted gray is these faces. Okay, this is not very obvious, not very clear. I'll use another color, a bright color for, let's say. Yeah, this one. This is super clear. So these faces have been painted gray. Okay. And when we are trying to decide how many cubes must the question for the first bonus question is how many cubes we can say for sure, for certain, 100% that they have gray paint on them. Yeah, no matter one face or six faces. Yeah, as long as they have gray paint on them. Yeah. And according from what we can see for this diagram, there is only 12. Yeah, let me count it for you. This is the first one. This is, okay, so again, a super unclear color. This is the first one. This is the second one. This is the third one. The fourth one, fifth one, sixth, seventh, eighth. Yeah, this is also the eighth. And then ninth. Oh, sorry, I made a mistake over there. Sorry. Yeah, this is the first one. This is the second one. And then the third one, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and the one in the middle, 12th. So altogether, we can see 12 cubes that definitely have gray paints on them. That's what we can see. Yeah. And as for other cubes, these 4 cubes, 1, 2, 3, 4, 5, 6, 7, 8, there's still one. Yeah. These 8 cubes, we see, first of all, the ones that are on the surface, 1, 2, 3, 4, 5, 6, 7, the 7 ones on the surface, we are sure that there is no paint on them. Yeah. And for the ones that are blocked by these cubes, yeah, the ones we cannot see, because we cannot see them, then we cannot say for sure that they have gray paints on them, right? We can only say for sure for the things we can see for our own eyes. Yeah, that's why the first question seems pretty easy. It's easier than you think. Does that answer the question? Yeah, is that explanation clear?
Yeah, thank you.
If it's clear, you can leave now, and actually not me. I'll see you the week after next week. Yeah, wish you enjoy the rest of the evening. See you, everyone. Bye.
Bye.
Bye bye.
Bye bye.
Bye bye
Bye. See
bye
you.
bye 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 bye.